Okay, now let's look at, I'm going to change this to n equal to 3. So I want to reproduce the neural network. I want to reproduce the neural network from the textbook, so we do set seed 1, and then here we want hidden equal to 3, and we are not going to specify any learning rate. Okay, and it's linear output equal to false. Well, actually, your textbook has 2 output nodes. So, well, anyway, let's look at how to now you do the prediction. So we have the predictions here. Now, how do we, remember, these are not probabilities. So these are the link functions. So from this, if you want to do prediction and confusion matrix, then we have to do the prediction ourselves. So, so let's call it NN1 pred. So one way of doing that is to use the if-else. Okay, and we're going to use the results. So these are stored in, so when you do a predict, okay, so these values are already there in, so if you do NN1 dollar net results, okay, so that's what the prediction is. Okay, so that's where predictions are stored, okay, for the data with which we did the training. So NN1.net results, or we can do this. Let's say NN1.pred, which will give the same thing. Now, NN1.pred has the predictions. Okay, then we can use that NN1.pred. Okay, so if this is less than 0.5, okay, then do the prediction. Otherwise, what the prediction is. Okay. Now we want to construct a confidence, we want to construct a confusion matrix. So the predictions that we are going to do with this code must match the actual values. So actual values are like and dislike. So we have to code it the same way. So if it is less than 0.5, then we say dislike. Otherwise, like. Okay. Then we can do a confusion matrix of, okay, so we have to make sure that this is a factor, which is NN1.pred. Okay, so well, we may want to give a different name. Let's say pred class. And then the actual ones. So as factor, tiny df acceptance. So you get the confusion matrix. All right. So this is a very small data, but still the code is the same. Well, if the data set is large, so you train the network, neural network model, and then you use the predict. And when you use predict, it predicts the value of the output from the output layer. So it's not probability, and we can approximately use it as probability. So you use 0.5, use that as the cutoff point to predict the clash, and then you use it for confidence interval. I'm sorry, confusion matrix. Okay.